Hey everyone, my name is Rochelle and welcome to another Discovery Crew video. Today I'm going to be introducing you to the scientist that I've been working with this summer. So I'm in college and I study neuroscience, which means basically I learn about how your brain works. And this summer I've been working with a professional scientist, so he's an expert in his field, and he has been working on tying together bioluminescence and neuroscience. I have with me today Dr. Christopher Moore. Hi, Dr. Moore. Could you tell us a bit about what kind of scientist you are?
Hi, Rochelle. I'm a brain scientist, which doesn't mean I use my brain. What it means is that I'm studying how different people use their brains and how different kinds of creatures use their brains so that they can walk around in the world and find food and survive and have fun.
Could you give me a one-sentence research question that you're studying?
The main thing that we study is how is it the case that you can be doing one thing, one moment, and then the next thing comes up and you're doing something else. So how is it that you can have this amazing ability to shift what you're paying attention to or what you're doing, and that you can do it in a moment? If you've ever been like at school talking to somebody in the hallway and someone says your name, say down the hall, and immediately you can shift your attention to that person who said your name. How does your brain switch like that? Your brain has this amazing ability to be able to move to whatever topic it most needs to focus on. That's what we study.
But what does that have to do with bioluminescence?
One way you can study this topic is trying to figure out which parts of your brain are in charge of letting you switch between different topics. Is it the front of your brain? Is it the back of your brain? Is it somewhere in the middle? To do that, you have to have some way of knowing what part of the brain was active at a given moment. Like if I can tell that every time I switch my attention, this spot right here in my brain was active, let's say this spot wasn't, just to make up a couple places in my brain, then that's a really good clue that if the brain area, this one right here, is active just at the moment I'm switching my attention, that's a pretty good clue for a scientist to think maybe that brain area has something to do with my ability to move and like suddenly pay attention to the person down the hall and then move my attention back to the person I'm talking to, or move it back to the teacher, for example.
Sure. And how can bioluminescence let you do that?
So first of all, bioluminescence is bio, meaning it works in living creatures, and luminescence, which is a fancy word for light. So it's basically living creature light. And so this is a kind of light that is produced by living things, from jellyfish to fireflies to all kinds of tiny, tiny microscopic organisms. Now, oftentimes, bioluminescence is produced by these creatures when some cell in their body, some part of their body is active. And it's often an indicator of that activity. So, why is that useful to us? Human brains don't glow, at least not very much. They do a tiny bit, but we won't get into that. If we could find tricks that would let us, say from a jellyfish, take those same small particles, those same chemicals that let the jellyfish glow when its cells are active, and we could put those into brains of mammals, human brains maybe even, then we could maybe just look at what part of the brain was literally glowing at the moment that you shift your attention. And we can use that glowing as a way of tracking the activity in the brain. And that would give us clues about which parts of the brain are important for things like paying attention in math class versus being able to focus on a baseball that you're trying to hit.
Wow, it sounds like there are some really cool applications for bioluminescence. What would you say are the coolest future directions of bioluminescence in science and in research?
So one of the really cool directions we're working on right now is that I talked about there being a spot in the brain that has to be active when you change your attention. Mm-hmm. Well, what that really means is that different parts of the brain will talk to each other differently when you're paying attention to different things. So let's say that I'm talking to you, Rochelle, and I'm listening to your voice really carefully. Let's say we're talking on the phone, and then I see something that I'm paying attention to. There's a part of my brain that deals with sounds and a part of my brain that deals with vision.
Okay.
And there's a switch between which parts of the brain are talking to each other as I focus on different things, either what I'm looking at, say on a TV screen, or a bird flying by, or a friend that I see, versus say the person I might be talking to or the thing I'm listening to on my phone. Mm-hmm. So as you switch from like a listening circuit to a seeing circuit, you're switching who's talking to each other. So one of the things we're trying to build right now is a way of actually making light a way of communicating in the brain. So that as you make those switches, you would actually increase the ability of one kind of pathway in the brain to be actually better at functioning. It would use the light as a way of driving, not just recording that the cell's active, but actually driving those cells to be more active. And if we can do that, and then maybe we could in some way increase people's ability to pay attention, say, to what they're looking at when they want to do that versus to what they're listening to when they want to do that.
Wow, that sounds really great. I appreciate you spending the time to talk with us about your research, and good luck with everything in the future.
I appreciate it. Good to talk to you.
That's it for today, folks. Thank you for tuning in. And if you liked what you saw, make sure to like and subscribe. Please check out our website, which is linked below if you have any tips or ideas that you'd like to share. Bye, crew. See you next time.